Welcome back guys on my channel. A few months ago I saw an image, so I decided to accept this challenge and remake it, adding some animation stuff and some tweaks in the composition. So let's dive in. I'm working with Blender version 4.1.1 and we can start making a simple plane with a Shift A mesh plane. We can go up in the plus button, General and Geometry Nodes, create a new geometry nodes with this new button, enable the snap tool, and instead of using the plane added, we can use a simple UV sphere for our earth. Press Shift Alt and click to see it in the viewport. We can increase the segment and the rings with the same value of 256, for example. And the first thing is to map the image of the earth you can find on internet on this surface. So to do this, we need to add a material we can call Earth, and because the UV sphere has inside a UV map not stored inside our geometry, we need to store this information to get it in the shading editor next. So to do this, I'm going to add a store name attribute, link these, Shift Alt and click to link the geometry output on the group output of the modifier. Change this point in face corner to have more accuracy in the interpolation values between the points of the mesh. Change the float into vector, link the UV map and set here UV map. And now we store the UV map of the mesh. If you want to see this unwrapping, you can easily add a set position node, link the geometry, link the UV map into the position and press Shift Ctrl and click, and you can see this representation of the UV map inside a square 1 by 1, and this is perfect to be able to stretch in a correct way and distribute in a correct way the image of the earth on the mesh. And you can see we have an effect of unwrapping, a perfect effect. If I decrease for a moment the segment to 32, and this is the final result. So we can take the rectangle image of the earth and let the system distribute this image on the faces of our mesh. We don't care if the border, the boundary of this mesh doesn't perfectly match with the boundary of the square 1 by 1. So in our case, and for the animation of this tutorial, we just need to have the correct distribution of the image inside our principal part of the mesh. So if you increase this value, you can decrease this issue on the border. Okay, so I deleted these nodes and select these two nodes, Ctrl J F2, save UV map. Now we need the image of the earth, and for this reason I can drop this group input, add a set material node here and link the earth material. Now I can go in the shading editor, and here I need to link a new image. I can press F3 and add an image texture, or I can drop directly the image file inside this space on Blender, and it would automatically create the image texture node. I can press open, search the file and select. And now if I link the color inside the base color, this is the result. Why? Because we have no information about the UV map, so the distribution vectors of the image on our mesh. And to do this, we can press F3 and add the attribute stored before inside the mesh. We called UV map, and link the vector inside this vector. And now we have the image on our sphere. You can see we have a sort of a mirroring of the image. So for this reason, we can easily take this object, press N to see sidebar zone, and we can rotate by 180 degrees on the X. And as you can see, we need to scale the X by -1 to have the correct America and other part of the world in a correct look. So we can smooth the surface of the globe, going in the geometry nodes and adding the set shading smooth, and if I enable the preview, all is correct. Now, why I took this image, this particular image with the lights? Because we need to distribute some object only on the part where the light is very high. So don't be scared if you don't have an image with a high resolution. This is not an image with a high resolution. It's an image near 2000 by 1000 pixels, but it's very good for our purpose. Now what we want is to add some statistic curve, so some cylinders on our surface based by these corners and lights. And to do this, we can add another material, statistics. We can increase the roughness to 1 and go down in the blend mode and select alpha hashed, because we are going to change the transparency, and in this case the alpha of this statistic curve on the surface. We are going to add some curves on the normal of this surface and change the scale of these curves based by the highlight and the lights of this of the zone of the image. But to have this information, we need to add the same image of the Earth inside our geometry nodes and use the same vector of the UV map of the UV sphere to read the same information of the faces on the mesh. To do this, we can add with F3 the image texture and select from this menu the lights. Now if I press Ctrl Shift and click, you don't see anything because we need to have a reference, a geometry reference, and to do this we need to do this operation. But as you can see, the wrong UV map info, so I can link the UV map of the sphere, and this is the result. I know it's a very poor, a very low resolution, but we can use it anyway. So now from this image texture, we need to use a color ramp to increase the surface of the lights and increase the surface where we want to distribute these curves. So if I link these, you can see all these in a grayscale. So I can decrease the white to have more distribution of the lights and use the constant technique to have only some spots, and we can set, for example, 0.014 to have this part of the word, and from this part we can add a new distribute points on faces. We can move these to output here and link the geometry inside. Now we can use this color to have the selection, and remember this value of white is equal to 1 for these points on the mesh, so it's perfect to select the correct points and global faces with a value of 1 on all the vertices that make the face. So in this case, this face is good for the distribution of a point, this also, and this not, because this vertex has a value less than 1, so the average of these 4 vertices has not value of 1, so will not be selected in this node. So now from this distribution of faces, now we can increase this value to 1200, for example, and now we can create a curve line to instantiate on our points. So I can link this in an instance on point node, link the curve line inside the instance, and we have the curves. Now we need to rotate the curves in the direction of the rotation based by these points made on the faces of the mesh. And we have for free these two information, the normal and the rotation, so we can link the rotation here and we have the correct rotation of the curves. We can decrease a little bit the length of this curve, but we are going to tweak the scale of the instances, and to be able to maintain the correct x and y value in the scale, I'm going to link this scale in a combine xyz node, leaving 1 and 1 in the y and the x, because I need to change the x information, that is this, because it's based by the end point of the original curve line that starts from 0 and go up on the z-axis. So what I want is to animate the scale of these curves based by a noise texture. I can add here. I can choose 4D because I want to link on the W value, so the changing of the pattern in the 3D space of the values of this noise. And before this, I can link these in a map range to be able to tweak the limits of the minimum and the maximum value of the scale of these curves, linking this result in the Z elements. I can link this W where in a scene information and in detail in the seconds we can decrease the roughness and the detail and leave only the scale. We need to maintain this check, so normalized, because we need values always be between 0 and 1, otherwise the node will give us values between -1 and 1, and for this map range it doesn't work correctly because we need to use a range between 0 and 1. If you want to turn it off, you can do it, but you need to change this from min to -1 to have the correct starting range. Now if I press play, you can see this behavior, so it's too fast. We can go in the output properties and select this to 30 fps, press play, and you can see it's too fast. So we can multiply the seconds with a low value to decrease the speed of the animation of these curves, for example 0.15 in this way, and we can tweak the maximum value of these random, we can say, values of the curves, but I want to add a little thing. I want to change this maximum based by the value of the luminance of the image. So I want to use the colors, the original color of the image on the surface, to tweak and to change the maximum value of this map range. So to do this, I can use this color and add it in a map range, but because Blender automatically connect this vector type in a vector map range, I want to be able to merge this information in an only one value, so I can drag the alpha and add this to a map range, drop the connection and link the color in the value. So in this way I can get only one value by the average of the 3 elements RGB of the image inside our map range node. Now we have a very simple image in JPG, so the value of the colors cannot be more than the perfect white. Okay, so the information of the colors inside the image cannot be over 1 in a range from 0 to 1. So if you are working with the image with a different format that can contain color values over than 1, keep in mind here we have the clamp checked, so all the values above 1 will be set to the max value in this range, in this output range. So we can increase this value to 0.02 to have a little minimum, and 0.8, link these where to the max of this map range, and in this way I can have this result here based by the lights of the original image of the world. We can tweak a little bit this curve, adding in the middle a float curve node, and link this result in the value, changing the curve to increase a little bit the lower values and decrease the higher value, like this, for example. Feel free to play with these values as you need. Now we have the curves and we can realize the instances, because in the output of this node we have only instances, but we need to work with curves. To transform the curve to mesh using a profile, we can use a simple circle curve inside, setting 8 for the resolution, because we are going to use an emission shader for this curve, so the number of resolution doesn't mind. We can check the fill caps, and here we can set the material of our curves, linking the statistics material. And now we can join together these two meshes. We can drop the viewer, and this is the final result. So as you can see, the radius of this circle is very high. We can decrease to 1 millimeter, press play, and this is the final result. Now, as you can see, we have a perfect cylinder for all these curves, so we can use a set curve radius node inside and change the radius to have low radius on the tip and a larger radius on the root. So for this reason we can add the spline parameter and take the factor that goes from 0 to 1 from the root to the tip, but we need to invert this information because the root is here and the tip is here. So the default factor would give us an information from 0 to 1, and the effect would be this, so the opposite. So to make the correct operation we need to add this to a map range and invert the range of values between 0 and 1 to 1 and 0, and link this to the radius of our curve radius, and this is the final result. Now we can select all these nodes, Ctrl J F2, statistic curves. Now because we are shifting and changing the scale of these cylinders, we can save the information to increase or decrease the color, the strength of the emission in the shading editor for all these pieces. So this value of the map range we used for the scale, we can store it with a store name attribute inside our distribute points on faces, and for each point save this information called, for example, random curve, and next we are going to use it in the shading editor. Now what we want on the surface of the globe are curves that start and end on the surface with a particular height. Here we can use simple 3 points for all these curves, rotate by the local z-axis to have a different rotation of the curve on the surface, and use the handle of each point to point them using the normal of the position of the point of the surface on which we will shift the control point of the curve. So the idea is to take a linear curve that has 3 control points. Then we will shift up based by the normal of the surface and get the shifted line. Then we are going to take the start and the end point and we will move them on the nearest point on the surface. And next we are going to tweak the length of the handles to make the beauty of the curve. So for this we can use the original geometry and add these to a distribute, points on the face, press Shift Ctrl and click. Oh my god, I don't see anything. Don't worry, the problem is that you can't see points information inside the preview material, so you need to go to the solid mode to see the correct result of the points, or use the wireframe mode to see the single point. We can increase a little bit this value. On this we can add an instance on point to move what? A single curve line, not a mesh line but a curve line, because the curve has handles, the mesh line not. So we can link these to the instance and link these to the viewer. But we have a problem. We need to shift the origin point of the line, because if I select only this line, Shift Ctrl and click to see only these, you can see the origin point of the line is here. I need to move this point here because this is the origin point of the line we want to be able to use to offset the curve along the normal of the surface of the globe. So we need to center the origin here, and to center the origin we can use a different axis because we don't want to use the Z component, because we need to use the Z component to shift along the normal, the curve on the surface, but we can use the X or the Y axis to have the other 2 points to move on the surface to get the correct bend effect, leaving the middle point as is. So to do this we can use the X-axis, so minus 1000 plus 1000 on the X and 0 on the Z-axis, and this is the single line. Now the instances of on point gives us this result, but as you can see we need to rotate this curve line following the rotation of the points on the faces, so we can link directly the rotation, and now we have the correct rotation of all these curves, where the middle point, the origin point, touches the surface of the Earth. But before this we need to set the position of the node of the points and shift along the normal of the surface a little bit to shift the curve on the atmosphere of the Earth. So we can add a set position here and link these in the instance of on point and use this offset. We can use the normal of the point, scale by a value, and link this on the offset. And as you can see, if I increase or decrease this value, we can shift the curves on the atmosphere of the globe. We can set this value to 0.1. Now, as I mentioned before, we need to have not 2 control points for each curve, but 3 points for each curve. So for this reason, I need to take this curve line and resample it using 3 count, okay, a start, a middle and an end point. Set the spline type not to poly but to Bezier, and set the handle type curve to auto to have the correct left and right handle available on this curve, and link these to the instance. Nothing changes. it's obvious. And now we can use the geometry proximity node to move the start and the end point of each curve on the surface itself. But before do it, we need to realize these instances in curves, because we have instances on the output of this node. Next, we can use the set position node, and instead of using for this selection the index node equal to 0 or equal to the maximum point or equal to 2 to get the correct start and end control points of the curve, Blender now has the famous node you can add with F3 and point selection. And with this node you can automatically start the selection from the start of the curve or the end of the curve based by the number of the control point you want to include in the set of the selection element. So in this case, because we have 3 control points, we can start with the first control point from the start and 1 control point from the end and leave the middle or the second point as is. So we can use this selection and we can add a geometry proximity. That is a node that can give us the position and distance between a source position related to a target geometry. So the target geometry is our geometry, that is this, the original geometry of the globe, and in this way I can get the position on the surface, and you can leave this empty, or if you are unsecure you can link this to the actual position of all the control points you want to offset. So the system will get the position information by the context of the linking of this node, so this set position, and I can link these here. I can link these to the geometry, and this is the final result. As you can see, all the initial and start point are now on the surface, but the handles are wrong, so we need to tweak this information, and also the rotation of each curve, because in this moment all the curve has the same direction and we don't want this. So if I mute for a moment these, as you can see, we have all the curves has the same rotation horizontally, and we can go here where we plugged the rotation inside this instance on point, and here we can add a rotation. So this node is perfect for this purpose because we have a rotation we want to rotate. So keep in mind the correct node when you want to rotate something, because depending on what you want to rotate and how you want to rotate, you would need a different rotate node. So in this case I need to rotate this rotation information by the local axis, so the axis already rotated on the rotation of the points of the on the face, and use this new coordinate system to rotate on the z-axis the point we have on this 3D space. So in this way we can link this rotation, and as you can see, if I increase or decrease the z component, we are starting to rotate the curves on the local z-axis. And to see better this result, I can join for a moment this in the final output, and you can see if I increase or decrease this rotation, you can see the correct rotation on the surface. Now we want to rotate by what? A random value between 0 and one entire round of values. So we can link these in what? In a random value, or there isn't a random value for rotation. So what we need is to use a random value, but not in a context of a float, but in a vector type, because we want to maintain a 0 rotation for the x and y and rotate only the z-axis. So this is the curve, this is the z-axis of the curve. The point has a new rotation on the surface, so the coordinate system follows this rotation, and now from this z-axis, the normal direction on the surface of the globe, we want to rotate the curve around this z-axis. So we can here set minus pi, so half of a round, and positive pi. If you don't remember the degrees, you can link these to the mean, a combine x, y, z value, and link here a value of degrees, so minus 180 degrees, and link inside this to a 2 radiant node, because I remember you, if you don't use the squeeze inside this rotation socket, but you plug everything from the external part, you need to use radians. And now you can link these to the Z and link these to the mean. The same for the max. I will drop these nodes and I'm going to use -pi for this purpose. Now to link this value to the rotate by, that is a rotation, I always use an intermediate node to rotation. In this way the system will convert this Euler information to rotation, and now I can link this to rotate by, and now we have the correct random rotation of all the curve on the surface. Now we can re-enable the set position of the start and end point on the surface, as you can see here, but the handle direction is wrong because we don't want to have this result here. We want to be able to move the handle to create a perfect perpendicular touch on the surface, and to do this we need to take the handle and move the handle in the direction of the normal of the touch from the control point and the surface of the globe. So for this I remember you this very important thing. If you have a curve like this and these are the indexes, so the curve starts from this point, the handles of the control point are these. The right handle goes to the direction of the curve, so this is the right handle. In the middle you have this situation here, okay? So this is the direction of the curve, and we have here the right handle, the left handle, the right handle, the left handle. So in our case, because we want to take the handles of this point, but not going through this direction here, but going to this direction here and here, because we want to have a curve like this, okay? It's a very bad drawing, but we understood the idea. We need to use the set handle position, that is this node here, but Blender can let you select at the same time the left and the right, so you need to use this node twice, one for the left handle and one for all the right handle. So all the left handles start with the index of 0, so we can use the same endpoint selection node to select all the starts control point of all these curves, and for this I can duplicate these and leave only one selection from the start, because we want to select what? The right handle, so this part of the handles of the control point, and not the left but the right, and link these. And for the final control points of all the curves we are going to use the same node, but starting from the end, because we want only this part of all the curves, but selecting the left handle because we want to modify this handle to going up following the normal on the surface. Rewind if you didn't understand perfectly this part. We can link this set handle position, and for both of these nodes we need to change the position of the handle, so this point here. Now in this schema the point is here of the right handle of this control point. We want to take this point and move this point here, and for the final point we want to move this point here. So this result point is equal to the position of the touching we got from this geometry proximity, so the position on the surface, and from this vector position we can add what? The normal vector on the surface scaled by a value. Scaled by a value because depending on this scale of value we can have a more bevel arc effect here for the curve, and we don't want to exaggerate with this scale. So this means that we need to start with this position here, and from this position we can add, pressing Alt S to switch the vectors, and we can add what? The normal on the same point. But to take this information we cannot use the geometry proximity, we need to use the sample nearest surface node. So we can choose the vector, and the simple nearest surface can get whatever attribute information you want based by a position on the surface. And this is perfectly because you could have a low poly mesh and you want to have the interpolated information on this surface between vertices of the mesh, and instead of using using the sample index that is specifically made to get the information on the single point, edge, face, etc., we need the interpolated point on the surface. That is the same operation that does this geometry proximity node for the position and the distance for free. So in this way we can link the same geometry information inside, we can use the same source position from which we want to get the other attribute you need. In this case we need to get the normal information on the surface, and now we have the normal. We can scale with a custom number, we are going to see it, and link this to the add. Now we can use this add to set the position of both of the handles. And now we can delete this annotation, and instead of join this on the final mesh, we can link this directly. Perfect. And now, as you can see, if I scale up or down, you can see the different effect of the curve and the curvature of this curve. For example, if I go here, you can see if I increase, you can see the handle here is very high. If I go down, you have a more stretched effect of the curve. Now we cannot increase too much this value because the shape of the curves would be very ugly. So we can set, for example, 0.1. We can decrease the general scale of all the instances, for example, 0.24. If you don't want to have this stretching effect of the curve in height, you can increase the distance of the curves from the surface, increasing this value here, so the set position of the distribute points on faces. So if I increase this to 0.3, as you can see, we have a more circular curves. And maybe I have an idea for another tutorial about the sun. Interesting. Do you remember anything from this strange shape? Who knows? So now that we have the curves, we can transform the curve to mesh, and for this we can use a curve circle, and for the same reason of before we can decrease the resolution to 3, for example, and let's set 0.5 for the radius of this circle to have this result here. Okay, as you can see, we have cylinders that has the same diameter for all the length, and we don't want this. We want to be able to have a value of the radius from 0 to 1 and then to 0 along the curve. So we can reuse the spline parameter and use this factor to set the curve radius here in the midpoint of this workflow, but we are linking the wrong socket, so this is the correct socket, but the values are wrong. Why? Because, as you remember, if you have the curve from here to here, we have the value of 0 at the start of the curve and the value of 1 to the end of the curve. We want to have a sort of ping-pong effect, and I remember you, the factor of the curve is a curve from 0 to 1 along the entire length of the curve. If you apply a ping-pong, you can have this ping-pong effect to 0.5, but the final and maximum value will be 0.5 for the value of the radius. So to be able to reset the correct maximum value, you need to divide this result by the same value used for the ping pong effect. Divided by 0.5 or multiplied by 2 is the same. I have lots of videos that describe this behavior. So we can take the factor and add a ping pong value to have a scale of 0.5 and divide this result by 0.5 to get again the same maximum value of 1 in the middle point of the curve. So now we can link these, and as you can see, we start with 0 radius, we go to 1, and then we go to 0 at the end of the curve. Now, before you use this curve to mesh, you can see the bad result of the resolution of the curve. I can increase a little bit the radius to let you see what I mean. As you can see, we have a bad resolution of the curve, even if you add here a resample curve. So if I add here a resample curve and increase this value, you can see after some values you don't have enough resolution. As you can see, why? Because in this moment you have a low resolution of the spline and not the problem of control points on the curve. So you can increase the resample of the curve, but the resolution of the spline will be always the same, and you have the same issue where you are in an environment when you add a curve like this. I shift it a little bit, and if I zoom in, as you can see, we have this bad result here. You can increase and make it better, increasing the resolution preview. So if you increase this resolution, you have a good quality, leaving the same 4 control points. So the problem is not a resample curve, but a resolution, because in this case we have a Bezier curve and not poly curve. So to fix this problem, we need to go inside our geometry node, and instead of using the resample curve, a bad node in this case that also decrease the performance of your PC, we need to add a set spline resolution node. And now if I go near my curves that has this bad resolution, I can increase these to 64, for example, and voila, the issue is gone. So also this decreases the performance of your PC while the animation, etc. So I suggest you, not only in this case, but feel free to experiment with this technique, because it's very useful when you want to have a good performance of your PC while the animation, is to add the ease viewport node and use this in a switch, and use it multiple times in the workflow. Feel free to use it. And in this case, I want to have a different integer number, and if I'm using the viewport, so I'm in Blender environment, I want to use a low resolution, so I can set, for example, 16, and if I am in a render mode, so I'm rendering something, I want a very high resolution, and this is very useful to maintain the correct performance of your PC. Link this output in the resolution, and all is done. Now we can link these to the set material node, and we can go in the material, add a new material, rename it in curves, and select these on the node, link the geometry on the final join geometry node here. Now we can select all these nodes, Ctrl J F2, curves. Now we need a last thing on our surface, so we need to add some spheres on our curves and have a loop where the sphere start from the beginning of the curve, follow the curve, and at the end loop again all the time. And to do this, we can start knowing that the number of the spheres is equal to the number of the curves, and the number of the curves depends from these distribute points on faces. So the exact number of these points are the same instance we want for our spheres. So we can link these distribution points on faces in an instance on point, and instead of using a UV sphere because it's not a perfect sphere, we can use an icosphere that has a better distribution of the faces, icosphere, and link this mesh inside the instance. Now we can join this result to the final setup. As you can see, the radius is too high. We need to decrease the value of the radius to 2 millimeters, for example, and have a double subdivision. Now, as you can see, the starting position of all these spheres is in the same position we made the curves. Now, the idea is to move the position of each of the icosphere along the corresponding curve. So, to do this, a bit of theory. So, we have, for example, 3 curves like this. Each of these one has the same length in a lowercase, and the total length is the L in the uppercase. The number of the curves is 3, so the same number of the points for our icosphere. Now what we want is to shift the position, for example, on the start of each length of each curve, and this is easy to do because if I divide the entire L by the number of the curves, we have the length of the single curve, and if we multiply by the index of each point, we have the value of the length on the entire length made by the sum of the single length of the curves. So 0 for this, L for this one, and 2 multiply L, because we have a 1 here, for the second, and so on. And from this value of the length, we can use the sample curve node that can give us the position on the curve based by the length value we set in the node itself. So we can try it, and for this, before instantiate the icosphere on the points, we need to change the position of this point along these curves. So to do this, we need the curves themselves. So we need to go here, before the curve to mesh, to have always the curves, get these and plug in a sample curve node. Inside we can add a set position node. We can increase for a moment the size of the icosphere, and we can set length because we want to use the length of all the curves, not one in particular, but all the curves. So in this way, if I plug this position here, I shifted all the icosphere in the position of the first curve. So I pressed Shift and Control here to the instance on point. And as you can see, if I increase the length, I pass all the points from one curve to a second, the third, the fourth, the fifth, etc. So through all the curves inside my 3D space. So I don't want these, I want to distribute each icosphere on a different position based by this length. So with our theory, we can take the curve length of the entire curve. So keep in mind that this value of the length is the sum of all the curves of the geometry passed through this socket. I can link these curves here, get the length, and this is L uppercase. We can divide this by what? By the number of the curve. So I can link this to a domain size, and changing the domain in curves, we have the spline counts, and now we have from this the lowercase l. So if I multiply this by what? By the index of each icosphere, I get what? The value in the starting point of all our curves. So if I drop these, as you can see, all these spheres start from the initial point of the curve related. Now the problem is to add to each of these icosphere a random value, and in some point where it goes to the end of the curve, loop again from the beginning. So what does it mean? It means that this value here is the starting point for all the loops. So all the icosphere need to have a loop in a range of values, okay, from n to m value, okay, inside this range. And for all the animation where there is this loop, we need to add the value of the starting position. In this way, we can take this range and always shift it by the starting point. And in this way, we can have a range of values for each icosphere that start from the beginning with a loop range, okay, and always the same. So we can keep these prefix number added on the loop values. What does it mean? It means that we can shift each of these icosphere from a value between 0 and the length itself, okay, adding some random values, but these random values can go over the maximum value of the L. So to keep the loop, we need to use a module related to L itself. In this way, if we add a random value and add a value based by the scene information, okay, the time, we always have a value that goes from a random point on this range. Every frame it goes forward, etc., etc., and each time it goes over the L, it turns back to 0. And with this range of values, add before or after, it's what? The starting point of each icosphere on the correct curve based by its index. So this value here, calculated by this formula we already have in the workflow. So this means we can move this a little bit. We can add a random value utilities starting from 0 to what? To the lowercase l. So this value here, okay, and this is the range from 0 to L. Now inside this random value we can add the animation, so a value based by the scene information, so the seconds, multiplying it by a little number to decrease the speed of the animation. Now from this output I could get a value greater than the L, so I am out from the correct range for the looping. So I need to use here a module based by the L itself to have the loop, Okay, so I have the random value, next frame, next frame, next frame, I go to the L value, next I have a reader value, I start again from 0, and so on. And this is my loop. From this loop, I can add what? The starting point, as you can see, the starting point for all the icospheres, so this value here, the lower L multiplied by the index of each icosphere, and in this way I can link these to the length. Now if I press play, as you can see, every time I can take, for example, this icosphere, every time this icosphere goes to the end, it will start from the beginning. So if I move like this, as you can see, we have again the same ball on the curve. And if I go again, I will start from 0, and so on for all the curves. We can collapse some nodes, and now we can reset the values of the radius of the icosphere to 2 mm to have a very little sphere on the curves. Now we can set the material of these spheres, adding another material, new balls, and we can set here balls. We can link these to the final geometry, and before finish this part, we can also decrease or increase the radius of these points to follow the radius of the curve. So using the same technique used for the curves. So I can add a spline parameter getting the factor of each curve. So keep in mind this value depends on each curve, so don't worry about these all curves. This value will be distributed using the length and we'll get the correct value of the factor inside each single curve of the entire set. So for this reason, we can use the same ping-pong workflow, scaling on 0.5 and divide by 0.5. In the same way, we can move these a little bit and link these to the value and use this value in a set point radius like this, and we can link this in the radius of each single point where we are going to instantiate the icosphere, and we can use the radius field to link and connect the scale of our icosphere. We can increase a little bit the radius of the icosphere to see the result. As you can see, if I go back and forth through the animation, you can see the radius of the sphere, the icosphere, that decreases, the start point that increases and then decreases again. Now we can select all these points, press Ctrl J, F2, balls, and now we need to go in the shading editor to tweak all the elements we have. We can enable the preview, go to the shading, and now we need to tweak the parameters to make the magic. We can start with the curve. It's very easy to do. We can delete this principle and use an emission shader, link these, set a strength of 0.5 with a yellowish color, and stop. The curves are done. Now let's make the balls. Same idea, emission color. We can drop this principle, link this to the emission with a Ctrl Shift pressed, a very high strength, and also here a yellowish color. Now for the statistics, if you remember, we stored the attribute information of the random curve value, so the value of the scaling of each of these little cylinders. So we can use it to mix an emission shader with a transparent BSDF. We can join them together with a mix shader and pressing Shift Ctrl and right drag between these two nodes, and use this factor as the mixing value. Link this to the surface, and this is the final result. So more big is the cylinder, more is visible. So because we are using the transparent BSDF, we need to tweak a little bit this value and make sure to have here in the blend mode of the material alpha hashed. For the emission, we can use a little green value and increase the strength like this. In this way, when the scale changes, will change also the transparency value inside this mix shader. Now for the earth, the shader is more complicated because with this bad and low resolution image, I want to be able to have a beautiful effect. So we can start to increase the contrast and the brightness of the image to have a good starting point for the base color. We can increase the roughness to 1 and set the specular to 0 to have no highlights on the surface because we want only emission and diffuse result. So from this color we want to modify the brightness and contrast, and using these values we have these without and with. With this information we can add a color ramp and change the position to 0.01 for the black, and for the white we can use 0.013 to have these clamped map. Then, because we have a linear values here, we can use a greater than 0.01 to have only or 0 or 1 values. Now from this we can use it in a mix but for colors, and link this to the factor and use these two colors to have the base color like this. Okay, we have the ocean, but instead of having the ocean as a unit color, we want a grid, and to make a grid following the UV map we can use the Voronoi texture, linking, it's obvious, the same UV map used for the image. Link only these. We can decrease the roughness and the random, change the type in distance to edges and increase to 25 to have this particular grid. As you can see, we have a stretched rectangular effect, so we need to tweak a little bit these, multiplying this vector twice to have a similar effect of squares, and I can increase twice these values to have more squares. And now from this I can use a color ramp. I can invert these two colors, have the white here and black here, to have these, because I want to have one color for the white and another color for the black. And we can decrease the black to have a value of 0.01 and have the correct grid. Now that we have this grid, we don't want the grid on the lens but only on the ocean, so we need to multiply this value by what? By not the greater than, because as you can see the greater than highlight the lens, so we need to multiply by black on the lens. So to do this we need to invert this color to have the opposite, because we need to multiply values and get a 0 factor. So we multiply these and the result is this. So we have the grid on the ocean and no grid on the lens. Now we can use this in a duplicated mix color, linking this in the factor, because we want this color for the ocean and this color for the grid. Next, we can use an height value here for the green zone of the lens and link this to the A part of this mixing, and this is the final result. We have the grid from this, and then thanks to this greater than node we have the difference color between the grid and this value. But I don't like this greater than as a factor for this mixing node. I want to have a grid of points to change the color between these two A and B. So to do this we need to multiply this greater than by another pattern made by another Voronoi texture, linking the same vector of the UV map. This is the final result. It's obvious. What I need is to decrease the roughness and random and scale up with a very high number, the number of these points, to 1000 for example. And as you can see we have a little stretched rectangle here, so as mentioned before we can use a multiply vector to make these rectangle as squares, so we can multiply by 1.63 and 1 to have more squares. And then from this Voronoi we can use another color ramp gradient to adjust this color, so the white can be on the point 0.191 and the black in the point 0.418. Now we can use this color to multiply this pattern and get this result here. And now I can use this for the factor of the base color, and this is the final result. It's better than before. Now let's make some tweaks for the emission of the lens itself. So we can start with the highest part of the image. So if I take the original image, from these I can use a color ramp, and before going forward we can select all these nodes, Ctrl J F2 points, and take all these nodes, Ctrl J F2 base color. Now from this color ramp that gives us all grayscale colors, we can tweak these values like these, 0.185 and white to 0.323 to have only this point on the surface. From this we can multiply this value by a high number for the emission or above the value of 1, so for example 10, and then we can multiply this result by the grid of the points to have only the colors on the points of this pattern. So we can use this in a multiply mathematical operation and link these two together, and this is the final result. So we have only the very high number value of the emission on the same point with the same grid, and to have a more dispersion of the emission we can take this map here, okay, and from this multiply what the original image to have not a single value of white, as you can see, but to have a more random value based by the lens itself, as you can see here, and add to this value the emission flash by the cities like this, and this is the final result. Okay, so we have the lens with colors that follow the image, adding the very bright emission from some particular parts of the image, and then we can link this to the strength of the emission and change the color of the emission in green. This is the final result, and voila. Now let's tweak the parameters of the camera. So we can go in the layout, press 0, make sure to have this toggle lock enabled, or if you don't have this version of Blender but a less version, you can go in the view section, and here you can check this camera to view. So I can go inside, enable the preview, move the position of the camera like this, for example, turn off this lock like this, go in the camera information, we can leave the focal length to 50, and we can decrease the clip start, we can enable the depth of field, but in this case we need an empty on the surface to have a better result. So I can exit from the camera and I can add an empty plane, and I can move with the G and Control press to get some vertex on the surface itself. Press 0, and inside the information of the camera select the empty object, and voila, we can decrease a little bit the f-stops like 2. We can go in the render properties, select the Eevee render engine, disable the bloom effect because we are going to use the compositor to add the glow effect, and because sometimes these kind of lines with the depth of field have bad result in the final rendering, I highly recommended to check these height qualities, light defocus and jitter camera to be able to get all the details in the rendering. So go in the screen space reflection. We don't have a reflection, but if you want to, you can enable it and increase the precision to 1. Enable the motion blur if you want to animate this scene. Go to the performance, flag the height quality normal, go to the shadow and increase to 1000 the cube size for the shadows, and flag the height bit depth. I know in this case we are using only emission shader, but if you want to add some elements that needs to create some shadow on the surface, you can use this technique. I suggest you to enable these parameters, go to the film, enable the transparent to don't see the effect of the world environment. We are going to add next, turn the simplify off, go to the color management, and here instead of using filmic, I suggest you to use the standard, or in the new version 4.2 to the Chronos transformer, because the saturation of the color is maintained in a more accurate way. Go in the output properties, select from the default the full HD, and here in the output you can set the images and set output value and press F 12 to have the first render image. Okay, with the render done, I decreased a little bit the radius of the circular curve here and decreased the radius of the icosphere to have a better result in the final render. And now we can go in the compositing editor. We can enable the use nodes, Ctrl+Shift+Click to see the render. And if you don't see the entire image, you can use the Alt and Home to fit the image inside your viewport. Now let's make some tweaks, and one is to add a glare effect, so the bloom effect. So we can choose the focal glow, height quality, decrease the size to have not much effort in the entire image. We can add a background color using a new texture, so we can add a texture input here, and to make a texture we can go here in the texture properties and add a new texture we can call background, and we can change these to clouds, so a sort of noise texture. Increase the size to 2, decrease the depth. We can choose this background here, and this is the final result if I press Shift, Ctrl and click. And from this we can add a color ramp to change the color of this texture, like this and like this. So the final image is this with a little noise effect. Now from this we can use an alpha over node, link the first image and link the second image, and this is the final result. Now from this we can add a lens distortion node, increasing a little bit of dispersion. And I remember you, the chromatic dispersion is what you see when you have an high contrast on a real shot, when you have an aberration and you have a strange line color depending on the contrast and the colors of the environment near the borders. And if I increase too much this color, you can see the big effect like this. So we don't need to increase too much this value, so I can leave this to 0.005 to have a very little effect here in this part of the image. And we can increase a little bit the distortion of the length, and because we have here the effect of the distortion, we need to fit and crop the image automatically. So to do this we can check this fit to crop the image, and next we can add a little grain effect using another texture. So I can click here to make a new texture for the grain, and here we can select a noise texture. We can add another time the texture inside our compositor and select this grain. Now we can multiply this color with this image here and see what happens. So as you can see, for the result the multiply factor is too much, so I can set 0.1 to simulate a realistic lens of a camera. And because maybe you are going to animate this scene, you already know that the grain needs to change while the animation. So instead of using a static image like this, a static texture, you need to offset this image in some way. One simple way is to use a value like this and set here the value of the frame, and in this way if I move frame one by one we have a different texture. I can link the final image in the composite to have the same result on the render view, pressing F11, and this is the final result. If you want to, you can go in the layout tab, and here in this menu you can enable the final rendering directly in the viewport and enable the compositor always inside your 3D viewport. Because we are using Eevee, maybe you can have a different result for the glowing effect than the real render result, so keep in mind this information. So that's it. Thank you guys for watching this video. I hope you learned something from this particular project. You can always download this project from my Gumroad page and other platforms. If you like it, please check a like, subscribe to my channel, and don't forget to check the bell icon to get all the notification of my new videos, and see you to the next tutorial. Bye!